Hello, in today's video, we will learn how we can do a z-test in R. That is, if you want to test for population mean, if the population standard deviation is given to us, how we can perform a z-based test in R. To do that, as again, let me share the screen and open up my R Studio. So here is my R Studio. Suppose the first question is posed like this. Suppose the IQ in a certain population is given to be normally distributed and it has a mean of 100 and a known value of standard deviation of sigma is equal to 15. So the population mean and the population standard deviation are given. A scientist wants to know if a new medication affects the IQ levels, so she recruits 20 patients to use it for 1 month and records the IQ levels at the end of the month. So the IQ of the 20 patients are given here with. So for this kind of an example, we have to test for mean. So the null hypothesis over here is H naught such that mu this is equal to 100 and the alternative hypothesis will be mu which is not equal to 100. So it is any number not equal to 100 because a scientist wants to know if a new medication simply affects the IQ levels, it can go lower, it can go higher. So the mu over it is not equal to. So this is a two-sided test. Okay. Now, to perform this kind of a test in R, we have to use a function called as z.test. However, the z.test is not available in basic R. To use this function, first we have to install our library. So install a package. First we have to install a package and then you have to call that library. So the first package that we will install is called as the BSDA. So we will be installing this package. Install.packages BSDA. So it takes a while to load. So this package is now being installed. Now we have to call this package. To call this package, we have to simply write library. So library BSDA. So if we just simply write library BSDA, this will call the package. Now the dataset whatever we have, first let me enter the dataset. Enter the dataset. Let me give the dataset name to be IQ. And to write this in R, we have to use the C function. C and then we can simply copy everything that is been given to us. Keep in mind over we have a hashtag, so because whenever we have hashtag that implies it has been commented out, so we will just remove that. So the IQ of the 20 students are given to us over here. Now we will be using the z-test. So the z.test, this is available only under this library BSDA. So we will use z.test and it has the functions called as x, y. So since we are just doing a one-sided z-test, we're not comparing between two values, we're just comparing of a one value based on a population mean. So over here, the x value is the variable that I have just entered, that is IQ. Now we want to test against the mu value of 100, the sigma value. So sigma, so we have sigma dot x or sigma dot y. So in this case, since it is one, we assume it is sigma dot x. So the value of the population standard deviation, this was given to us. The value of the population standard deviation was 15. So we have sigma dot x, this is equal to 15. And suppose we want to construct a 90% confidence interval. So the conf dot level is equal to 0.90. So if we hit enter, it gives us a value of the z-test. So this value that we have is a test statistic, is z equal to 0.9093. This is the test statistics value. We have the p value. We are testing against the alternative hypothesis that the true mean is not equal to 100. And we have the 90% confidence interval between 97.53 and 108. Also, we know that the mean of x, so the mean of these 20 numbers is equal to 103.05. So based on this example, we can conclude that we are not rejecting the null hypothesis. So the new medication does not affect the IQ levels, and we can claim that the new IQ level is not different from the value of 100. So based on the z.test, which is available in the BSDA package, we can test for one sample z-test. So we use the IQ, that is a data set, the mu that we are testing against. Sigma dot x represents a true population standard deviation that is given to us, and over here we are constructing for a 90% confidence interval. Similarly, we can also construct for a 95 or even a 99% confidence interval as well. So if I construct for a 95% confidence interval, I have to simply change this number from 90 to 95. So this will give me an estimate of a 95% confidence interval. Everything remains the same. So if we compare this set of numbers with this, everything is same. Only thing that changes is the confidence interval part. So 90% and the 95%. So that's all we have for this lecture. Thank you.